Hi, let's talk about bad test today.
Yeah.
Because we tried to talk about good test, but it was a little bit difficult to formalize. I think we will have much more passion talking about the things that make our life more difficult.
Yeah.
Let's take turns. Bart,
Yeah.
let's start
All
with
right.
you. Tell me
Excellent.
something about the bad test.
So, one of my personal gripes with bad tests is that often they just don't seem to get the attention that like production code gets. So you see just like basic things that you wouldn't accept in production code done wrong in test code because it's just test code, which pisses me off immensely because it's just as important part of your code base, and maybe an even more important part than your production code. So I think that's my number one gripe.
I absolutely agree with you. That's one of the high level for me. I don't think many people will disagree with this, that we should treat our test code as a first class when we're just talking about this. But somehow in practice, many people forget and neglect this just because it's just a test code.
I must admit that when I do code review and I'm struggling for time, I will skip tests before I skip production code. And I think this is that same mechanism. So even though it pisses me off personally,
There is some natural tendency, which is very difficult to fight indeed. That's one thing. When we don't have enough time and we say, okay, we can polish this a little bit maybe later in follow-ups if it's necessary. But I think another thing is also that people don't see it's reasonable to spend much time on tests. I hear sometimes, why do I need to spend that much time on tests? Well, honestly, I think, it depends on the situation, it depends on your context, but I've seen cases where it was perfectly fine to spend 10 times more time on tests than on your production code because there was a value of that.
Yes.
So it's more about the value. So that's another reason, I think the reason why sometimes we see underappreciated test code. And I would also like to agree with you strongly when you said that tests might need even sometimes better attention. I think test code is more difficult because the readability is even more important than in production code. It is important also in production, but negative effects of unreadable production code sometimes are slightly less of magnitude than unreadable test code.
That's interesting. Why exactly?
Because it will be neglected again.
Right, yeah.
Because if you have unreadable production code, especially in the important areas, you will see it, you will spend your time on reading this and maybe refactoring this. But if you have unreadable test code and you don't have this habit of refactoring it, treating as a first code, chances it will be getting even more and more unreadable.
Yeah, that's very, very true. So you're saying this natural tendency to focus only on production code exacerbates any kind of broken window effect that you could have in your code.
And broken window is also perfect. You sometimes ask in the pull requests, if you do have time to go scroll down to the test, okay, why are we doing this here? Why are we doing this here? Can't we just extract the function? So, I just copied the test from somewhere else.
Yes. Yeah.
Yes. But now that we're talking about this, all fully perfectly agree. I would also like to add there is another side of this, because most of the problems or bad smells, we have another side. When the test code is too minimalistic, too optimized, it can also be a negative side.
Yes.
It's also not always as good on production code. You can sometimes to make it too dry, over dry.
Yeah,
so it would be it will be less repetitive but more difficult to reason.
Yeah.
I think it's even stronger on the test side because tests are much more explicit for readability, and so many things are good to repeat there explicitly, have it in your face what is important. So when we're following very blindly mechanistically dry and minimalistic approaches, that can lead to less readable, less explicit tests. I think.
Yeah, it's maybe sad for the discussion, but I wholeheartedly agree. Tests need more duplication than production code. That's you want your inputs explicit, you want your asserts explicit, and you want your call under test explicit. And the only thing that you want to extract is setup code that's on a different level of abstraction. That's basically it.
That's not important for understanding the test.
Yes, exactly.
Important technique that many people do it wrong. They either put all the details at the beginning of your test, where you don't really care about the test, or they will collapse something and say, given I have this state, and you don't know, okay, it's too generic, I don't know what is in the state, how did you get to this order number or whatever? Yeah. Is it something that is known, or how did you derive it?
Yeah, and that's also, I think, a perfect example of how test code is harder than production-like code, because this judgment of what do you need to put in the test and what do you need to abstract away is so much more relevant to the readability of a test.
Yes. Another point that I have is slow tests. But not necessarily just slow, unnecessary slow. If we have the same tests, same readability, and the one implementation is much faster, of course we will always say we want to have faster. We don't want to have tests to be slow, especially unnecessary. My point here is unnecessary. But we also don't want to push it too much into the fast, because if we're making them too fast, we may make compromises that will make the maintainability of the tests not that good. My example would be at bol.com when I worked with one of the platform teams about a tool, Stanley, that brings data to the cloud, to the BigQuery of Google Cloud. So there we had lots of unit tests, cover things, but at the end it didn't matter at all until you go and run it against the real BigQuery. So we had to rely on the system integration tests that we would run on real environments with real tables created and deleted. We could not work this around. And it was horribly slow. Well, not horribly, like tens of minutes, 20 minutes, I think, the whole suite. But in that particular case, I would not trade it for a set of much faster unit tests, because they would just give me, okay, the SQL produced or some kind of call is what you wanted to produce, but how it works together. What is the end result? Can you reason about this without having everything in your mind? That in that context was not working. So I would not push, in that case, those tests to be faster. So that was natural slowness. And that was a cautious compromise, cautious cost that I wanted to pay. But I much often see unnecessary slow tests, especially in Java world, in the integration level, where we as people, Java developers, put all the techniques. There are a huge amount of techniques, especially in Spring, how you can test things. And that's good. But when they are put in without much consideration, they can make your tests very slow. And then you will try to avoid writing those tests.
Yeah, so you're talking about unnecessarily dirtying Spring contacts and stuff like that?
Of course, if we were talking about Spring, yes, these techniques. Yeah. But I would not be surprised if in other stacks there are other things like that developers are not paying attention and they're just slowing down. Basically, to keep nothing is coming for free. To keep your test suite usable and reliable and not unnecessarily slow, you will need to spend time on it. Not only about readability of the code, but also thinking how to build your architecture of your tests.
Yeah.
I have one more point, but I would like you to add if you have anything.
Yeah, okay, well, because I have a particular gripe about asynchronous tests, which are a skill in itself to write. And what always pisses me off is tests that sleep or wait, essentially. They say just wait for a second and then do your assertion and then assume that what you want to have happens within a second. I mean, usually with unit tests, you definitely want, or any tests for that matter, you want to have it happen within a second. But it's much better to concretely validate an expectant state and use something like a waitility to check that like every 5 milliseconds or every 10 milliseconds than it is to say, I'll just do nothing now and then hope things resolved. So that's one of the smaller things about.
Yeah, but I agree with that. Is that it's very important never to just blindly sleep once, because technically, from theoretical point, our utility does almost the same. The most important thing is that just it doesn't wait for the whole thing. No. It checks all the time in between, and that means that you're not slowing down again unnecessary your whole suite to maximum possible time that would take without making your suite flaky.
Yeah,
and it's a very simple technique. If you don't have a tool like Awaitility in your language, I guess there is something else, but even manually it's very easy to implement in every language, and it's really surprising how often you start to encounter thread sleep in your test code. I absolutely agree with you on that.
Yeah.
So I have another big point. In here, I won't talk about individual tests, maybe even that much, about the test suites. And here I would say, I don't think your test suite is good when it is prone to ripple effects. And what I mean by ripple effects is that I have some logic somewhere, and for example, I'm doing a enrichment call to other service or something, and I decide to move it around, to move it slightly to a different service because of whatever reasons, to refactor basically. And then if I move this thing, and then you have many tests that are starting to fall down just because they were mocked with lots of expectations, and just these expectations that was mocked is starting to fall apart, that's a very bad sign. That means most probably those tests are either testing on the wrong level, they should have been on the lower level and refactor the code so they are not affected by those changes. Or the setup of your test suite is not optimal from the point of resilience to the change. And there are different techniques how to find it, but for me that's a big symptom that probably the test suite is preventing us from doing refactoring. And I am very sad to hear it again and again in many different contexts and in many different teams. Yes, okay, it would be nice to refactor this, but we will not be doing because or maybe it will be a much bigger time because, all these tests we need to go through individually and change the assertions.
To me, it feels like more a system smell than a test smell. But it might be both, actually.
Not necessarily. I think I see this often in normally designed systems.
Right.
The main suspect here is mocks.
Yes.
And the tests that are on a slightly lower level, not like really on integration, but pretending to be unit tests while not being unit tests or somewhere in between.
Yeah, because
where you have huge clusters of mocked expectations and validations, which
are tightly coupled to the actual...
tightly coupled to implementation, and where you called with which parameters and so on.
Yeah.
So it's not necessarily implementation. And somehow I suffer from that a lot. I don't know. Maybe it's me happy to get into those situations.
Maybe it's a bit of a digression here, but why do you think we encounter this so much? This overuse of mocking and this tight coupling between architecture and unit tests?
I think there are many misconceptions.
Right.
Just some rules that are heard and misapplied in a different context. Like in our discussion today, I had this, we don't want to have slow tests, but that doesn't necessarily mean that we should move them and make them lightning fast. That they might be naturally slow and bring enough value.
It's very easy to write lightning fast bad tests.
Exactly. So, and that's another what I hear often when I ask, why are we having that huge amount of the mock things and not just refactor thing? And that can be the answer. The most blatant, it's just easy to write it like this because it's very nice with the modern mocks, very easy and sweet to write tests. You just mock it, it's perfect. I really like doing that. But the cost of that,
Yeah.
So you need to be thinking about what will be when we will be changing those tests, those implementations that we're testing. So that's one thing. Another misconception over here, interesting also, like, oh yeah, but if we are starting to test small individual things, like, okay, we don't test the whole service, for example, there is a small piece of functionality that has the value. I say, okay, why not to test just this with a very focused unit test? Oh, but then we're actually testing the implementation. No, we want to test the whole thing with everything mocked and intercept the calls, pretending that we're not testing implementation, because we don't want to make some internal method public or package local just for testing, because it's a bad sign. Which to me, again, misapplication, misunderstanding of what we mean by saying testing implementation and why we don't want to test implementation. And that sometimes it's also okay to test even implementation if it's very isolated and unit test, and if there is a value in that.
Yeah, so I think we now, you just mentioned a couple more signs of bad tests that we haven't even addressed yet. So it might be interesting to do another episode about bad tests. And what we just started exploring is why do people write bad tests, which is a whole new subject in itself, and maybe that's something we can go into.
I think it's very important in this equation, because it's not people are bad intentioned or
no, definitely not
something. But it's strange how often it happens.
Yeah,
let's talk about this. Cool,
awesome. All right, so then we'll have another one on more crap from tests, and we'll have another one of why do people write bad tests? Why do we write bad tests?
Yes.
Let's make it honest.
Well, guilty.
Exactly. Yeah. All right. Thanks. Bye-bye.